Because we didn't do it the other day. So again, the frequency we start with is the number of data points. The mean was simply the average. We talked about that already. Okay, and then Kelly again, sorry, again, one more time, say it. The median, what do you think of?
If you think of like the graph in the middle of like two roads, like it says median, so you won't like drive over it.
So a car is driving this way on one side of the road, another car is driving this way. And there's this strip of land in between, right? So you're on like a highway. It's called the median. The median is the middle of the road. So when you think of data, think of the middle point in the data set. Now, if you have the middle point, what do I have to know about that data? What does it have to be in? In order. Okay? So in the middle, good idea with the order, very good. Middle data point in an ordered set. In an ordered set. Okay? In an ordered set. Again, this is, just so we know, Concept 64. We started recording a little late. So, the middle data point. Now, what happens though? What happens if there's no middle data point?
You divide them the two that you have.
You divide them?
No, you add them, and then you divide them by two.
Which is called finding the what?
The mean, the average.
The average or the mean of the middle two. So take a look. If I've got a data set of 2, 7, 9, and 12, there's no middle number here. Again, the middle occurs right here. That's where the middle is. It splits it in half. So since there's no middle number, I have to average these two numbers. Again, the average of the two middle numbers. Okay, so for your notes, you might want to write that down. When there's no middle number, you average the two middle numbers. The middle two numbers averaged. The middle two numbers averaged. All right, what about mode? What about mode?
The one that comes up.
Good. The most commonly occurring number, or the most frequently, using frequency again, the most frequently occurring number. The most frequency occurring number. Again, let's take a look at an example that does not work too well. What if I have, by the way, it's good to have everything in order for the median, mode, and range. The mean, though, the data does not have to be in order, really, because you're adding them up anyway, so it doesn't matter. But for these three, it's good to have them in order. So if I have 2, 2, 4, 7, 8, 12, 12, 18, 27, what's my mode?
2 and 12.
Good. So, a lot of people think it's the same as the median, you take the average. That's not true. So those are the modes. So what do we call when there's more than one mode?
Mode, double mode.
Everybody's been saying double mode, which is fine. That's fine. It's actually called, though, bimodal. 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 Okay? Like binocular. Very good. There's two parts to it. Or bicycle. So, bimodal. M-O-D-A-L. Bimodal. M-O-D-A-L there. Not E-L. That would be bimodal. Okay? B-I-M-O-D-A-L. All right, so mode is the most frequently occurring number. And finally, what about the range? What about the range?
Oh, you add all the numbers.
Isn't it like the biggest number and the lowest number and you add?
Good, very good. Melody, I want to hear you one more time. Go ahead. You got it right, though. I want everybody to hear you. You don't want to be on the recording, do you? Melissa, what's the range?
Like when you add the maximum and the minimum.
When you add them?
You subtract them.
Thank you. And that's more than you need to say. That's all I would write. Max minus min. Okay, no need to go any further. Largest minus smallest. The difference between the endpoints. Doesn't matter what you say. Think of the max value minus the minimum value. Okay? All right, let's go to number 1, please. Let's take a look at the first one. Now, number 1 is going to be our most basic example. We're just going to calculate. After that, we're going to look at where we see this stuff. Okay, number 1 is just very basic. So we got the speeds, miles per hour, of a baseball thrown by Nolan Wright in an at-bat were listed as 83, 89, 85, 94, 77, 90, and then back to 85. So we've got a low extreme here. The lowest value is my 77. Maybe that was like a curveball, right?
Yep.
Then my highest value is 94. That might have been like a four-seam fastball, which is a little faster. So we got an end point of each of these that are largest and smallest. What should I do for my data if I want to find all these values before I begin?
Put them in order.
Good. Again, the mean, it doesn't matter the order. But since we're going to need to put them in order for the other ones anyway, we might as well do it first. Okay? Now, here's my recommendation. My recommendation here is that you start with the smallest and cross it off once you use it. So start by writing the smallest, then cross it off your list, please, so you don't do it again. Okay, to make it easier on you. Next, 83. Good, so there's two 85s, notice. Thank you, Eddie. It helps a lot. So, again, I notice here that my data is now in order. When my data is in order, what can I say about the median? The median in this problem.
It's 85.
Why, Karen? Which 85 though? There's two of them.
Doesn't matter.
But in this case, the median, which one is it really? The one here or here? Good. Again, because there's three data points here, therefore 85 is the middle. The middle. Now, what's the mode?
Isn't the mode 85?
It's also 85 because it occurs twice. The mode occurs twice, or the most out of all the data. So we've got median is 85. We've got a mode of 85. Before we get to the average, let's do the range next because these are easier. What's the range going to be? What minus what? Say it one more time.
94 minus 77.
Thank you. I heard 77 minus 94. Be careful.
17.
Okay. 17. The max minus the mid. Okay. Max minus the mid. All right. Now let's do the average over here. Again, remember, for the mean, it does not matter if the data is in order or not. But since it's already in order now, we might as well use it that way. So what do I do for the numerator? I'm not going to have enough room. Use your calculator, please. Okay. I put all my data up top. What goes in the bottom now?
7.
Why 7, Barbosa?
7.
Well done. The frequency is 7. There are 7 values. Now, this equals the average, right? This equals the average. I'm going to move this over. So, the terminology for the average, just so you guys know, is X bar. And here's how you write it. X with a flat bar over it, or horizontal line. That means average, in case you see it again. Okay, X bar. So X bar is 86.1 approximately, right? Approximately. So we've got our mean, median, mode, and range. Is that pretty straightforward?
Yeah.
I hope we've all done this. Let's get into the real problems now. Okay, let's take a look at example 2. Take a look at example 2. Please read it to yourself. It's on your paper. Please read it to yourself. We've got a student that receives grades of 85, 90, 92, 77, 83, 98. What is the minimum grade the student needs on his or her, in this case her next test in order to have an average of at least 87? Some of you have asked me this question before. How do I get an 87? How do I pass? How do I get a B? How do I get an A? How do I get a C? right? All these questions. This is how you do it. We're going to show right now. So, the person wants an average of 87. And what's our formula again? X bar equals what? Thank you, Kelly. Come on, people, let's focus. Sum over frequency. Now, the problem is this. I know the average this time, don't I? What's the average going to be? What does she want the average to be? 87. So I can put that in already. Up top, though, what do I have to do?
You put that, and then, yeah, all the numbers up top, right?
Good.
So 85, or does it matter what order you go in?
No, it's mean, remember? Mean doesn't matter.
Plus, yeah, all that. Divided by 6, yeah.
Okay, what's the problem with that, though? Who can tell us? It doesn't equal 87, guys.
So divide it by 7.
Here's the problem. We don't know what her next test is going to be, do we?
No.
So what should I put in the numerator up there? Plus x. Very good. The numerator needs an x in it. Okay, my numerator, you need to know what the unknown value is, right? That's what we're trying to find. Her grade on the 7th test. We have 6 tests, but it says, what is the grade on her next test? This is the 7th test in the datum. So now I have a 7 in the bottom. Again, the unknown is x. That's the next test grade. So, next. I want to get x, don't I?
Yeah.
How do I get rid of this annoying little 7 in the bottom?
You add all the numbers and divide it.
Easier way. How do I get rid of that 7? Good, multiply it. It's being divided right now, right? So if you multiply both sides by 7, or just simply bring the 7 up, these 7's cancel, don't they? So I get 7 times 87 here. So we get 609 equals, now, x plus, what's the sum of all those numbers? Anybody do it yet?
525.
Good, 525. Again, lump these numbers together, please, into one number, and that number is 525. And now subtract it, please. It's being divided, right? 7 is dividing with this, so you have to multiply, or just simply take the 7 and move it up over here. Because if you multiply by 7 here, the 7's cancel, and you're not putting 7 over here now. So simply take that 7 and move it up. And Eddie, so this. Take the 7 and just move it up over here every time it works. Whenever there's a fraction, okay? So we get 84. Okay, now my next question to ask you is this. The problem said, what is the minimum grade she'll need to get an 87? And it was an 84. But what if she's not settling with an 87? She's like, you know what? A B plus is not good enough. I want to get A minus. So now she wants to get a 90, right? What's my answer going to be, theoretically? Not the exact number, but theoretically.
87.
No, you're just adding 3 there, Karen. That's why. If her average is an 87, the grade she needed was an 84. But if she wants to get a better average than that, what does she have to get here?
Like a 90?
Anything above an 84.
Thank you. Exactly. Theoretically, that's why I said that. Anything above an 84, right?
Yeah.
So if she wants an average better than an 87, she needs a grade better than an 84. If she doesn't care and says, all right, you know what, I can take an 85, then she could probably take a number a little less than this, right? So you got to think about that when you're going through these problems. Okay, the minimum value. Number 3. Now, numbers 3 and 4, take a look at what it says in your directions in italics at the top. What does it say? Somebody read the italics.
Using right to answer push back except between.
Good. Use the histogram to the right to answer examples 3 and 4. The SAT does this a lot. They give you one diagram and say answer the next 2 questions based on that.
Yeah.
You need to read directions. You know how many people answer the first question and then they don't know that the diagram refers to the next one? And then they try to answer the next one, they don't know what to do. Again, the diagram refers to both questions here. Both questions 3 and 4. All right. Number 3 is very, very easy. Read it to yourself, please, and think about what you're doing. And think about what you're doing here. What word should I underline in this whole thing?
Range.
Range. And what is range again?
Max and the min.
What's the max in this case? Right here, right? So what's 10 minus 2?
8.
That's it. Choice C. That would be an easy level question, just so you know, on the SAT. There's easy, medium, difficult, that's easy. Again, 10 is the max, 2 is the min, 10 minus 2 is simply 8. Now, if you didn't know that right away, it might help to do this. Take a quick look at this data, everybody. Is there a mode?
No,
Why is there no mode, Kelly?
because there's no repeating.
Sure, or there's no number that occurs more frequently. You can have repeating numbers with no mode. If every number occurred twice, there's still no mode. The mode is the most occurring number. So there's no number that occurs more than any other number. Be careful, please. There's no number that occurs more than any other number. Okay? So in this case, there is no mode. There is no mode for this problem. Let's go to the next problem. Same diagram again. The average hours of daily sunshine for the week occurs once during the week. The average occurs once. What day does this happen on? So what am I asked to find? The average or the mean. Very good. The mean. So we add them up again. Let's do it. 7 plus 6 plus 2 plus 8 plus 4 plus 5 plus 10, giving me 42 total. Now, what do I divide my average, my sum by? Good, the frequency. And there are 7 days, Sunday through Saturday. 42 over 7 is? When is the average occurring? What day?
Monday.
Monday. Look at Monday. On Monday, you're up at 6. So your answer is Monday. That would be a medium question on the SAT. Again, the total sum is all the days of hours added up, giving us 42. So when I add up all these numbers here, I get 42. Then I take that 42 and divide by 7, because there are 7 days in the week, which tells me that every day there's an average of 6 hours of sunlight. 6 hours occurs on what day? On Monday. On Monday. Questions on this one? Okay, they're going to get harder. Just get ready. Next one. I'm going to give you 1 minute to write down what you think you should do. 1 minute, begin. It's not an easy question. Write down what you think you would do. I'll give you a solid minute to think about it. Seconds, and I'll hear some suggestions maybe. All right, what do you got? What should I do to start this problem? Nobody knows? We're still working.
What about average?
It makes no sense.
Sure it does.
We find the average.
The average of the integers here
It equals 11.
is 11. So I start by saying 11 equals my average, whatever I get. Okay? So what is the sum of these numbers? 24 plus 6 plus 12 plus x plus y. Those are my integer values, aren't they?
Yeah.
Now, how many of them are there?
4, 5.
There are 5. Be careful, there are 5.
And then you solve. 1, 2, 3.
Now, move the 5 up. Take the 5, move it on up. We get 55 equals. What do these 3 sum up to be?
42.
Now, here's where people get confused. You know how many people try to find x or try to find y? But you can't. You cannot find x or y individually because there's 2 variables in one equation. It's not solvable. But if you think of x plus y as an entity, you think of it this way now. Watch what I'm going to do. In my mind, here's what I have written down. What does triangle mean?
Change.
Or just, it doesn't change, sorry. Just some variable, right? Some symbol. So if I think of x plus y, because I'm trying to find, what does it say? what is the value of the sum of x and y? Well, the sum of x and y is this triangle right here. I've replaced it right there. This right here, that's the sum of x plus y. I'm going to call it triangle, and now solve for triangle. How do you move the 42 over? So 13 equals triangle. So the sum of x plus y is 13. Again, it's a dummy variable, it's called. It doesn't matter. I know. Dummy. It's the real word.
Put like a happy face there.
Sure, you could, on the SAT they do that a lot. They'll put like this. They'll do a problem like this. 2 triangle plus 3 square equals 28. If triangle is double the square and square is this value, what does this equal? That's what they'll do. So you have to plug in. But triangle and square or rectangle, whatever it is, it's just a variable. Remember the definition of a variable. It's a symbol that takes the place of a number. We have chosen to use alphabetic symbols, right? X, Y, Z, A, B, C. Why can't it be shapes? You want to see something cool? So, I was making a calculus review sheet for my calc class the other day, and I was trying to explain to them the same thing. That it doesn't matter what the variable is. It matters that you have a symbol there. And look at the formula sheet I used. What do you notice on here? I used all different triangles and squares and stuff instead of x's and y's, just to indicate that it doesn't matter if I use variables or other symbols. It's the exact same thing. So every time you see a square, it's an x maybe. And every time you see a y, maybe that's your z. But it doesn't really matter, okay? X is just a symbol. Triangle, square, they're just symbols. So when you get to this test on Saturday and you see that symbol, you think, oh, that's just a variable. That's all it is. Okay, it's just a variable. Next one. This is a really good problem. Try and take 30 seconds this time to write down your equation you're going to use. 30 seconds, go. Again, just write down the equation you should use. Okay, 30 seconds. Anybody got an equation for me that they use to start with, just to start the problem? Now, I'm not asking for an answer, just a starting point. Karen.
Is it 22 equals x plus x plus x divided by 3?
Close.
Oh, yeah.
Why do I have to use different variables, guys?
Distinct.
Distinct means different. Distinct means different.
Yeah.
Okay? Now, the numbers are going to be positive. It says that, right?
Yeah.
So we know x, y, and z cannot be negative to start. Now, move the 3 up, please. Okay, 66 equals x plus y plus z. But take a look, guys. How many variables do I have again? 3. And only one equation, right? So I can't solve just yet. This is where intuition comes in. So pause for a second and think about a scenario I'm about to tell you. Who likes pizza? Okay, me. I know earlier time I showed you pizza, right? So imagine you got a pizza pie, and we're going to split it, me and you. And we can't have half slices, only full slices. You want as much pizza as you can get, but I have to get some. What would you give me then? You're right.
A bite.
How much? 1 slice, right? How many would you give it up with?
7.
7 slices. What did she do?
She got the biggest amount.
She got the biggest amount because she gave me the
One.
smallest. So if we want one of these numbers to be really big, what should we do to the other two? Make them small. So call this 1 and call this 2. Why do I have to start at 1? Because the numbers are positive. What's the smallest positive number you know? That's also an integer. Remember, integer are the whole numbers. Only integers. So if it's an integer, you got to have a 1 here. This has got to be a 2 here. Why are these different?
They're 1 and 2.
Why did I have to choose? Why couldn't I do 1 and 1?
Because they're distinct.
Distinct. So I start by doing this now, and now take a look. You solve for z. Z is choice B, 63. So here's what you should be writing down now as a conclusion for this problem. If you minimize x and z, X and Y, X and Y. If you minimize X and Y, then by default you are maximizing Z. Again, because I said if you want the most, that's the best way to do it. You're smart. I thought you would get it. Again, you could have said 2, right? You could have said like, oh, I can't eat more than 6, but assuming you can eat as many as possible, just like this problem. No, not realistic. That's a lot of pizza. Okay? So again, whoops, Z equals 63. Z equals 63. Okay? Again, I chose 1 and 2 for those values there.
But you could have chosen 1 and 1.
Why couldn't I choose 1 and 1? It says they're all distinct. 3 distinct integers. When they're distinct, Andy, they have to be different. I agree with you. If they didn't say that, it'd be 1, 1, 64. And take a look. That's why choice A is there. See that? Okay. Number 7. Number 7 was probably the second hardest one out of this set. The next one's hardest by far. But this one is tough. And a lot of people got confused. The wording is so poorly done. But this is an example of an SAT problem. It's the kind of wording you're going to see, unfortunately.
Why did they do that? Like, why is it legal?
Why are they evil?
Why is it legal? No, why did they allow it? Like, why? Yeah, like, why is it legal?
I don't know, guys. It's just, they're trying to get you to think critically, and sometimes it does help, but sometimes I'm not a big fan of the wording, because it's very vague, okay? Very vague. So let's analyze this and break it down together. The graph above, well, below, the graph below illustrates the number of box tops collected by 4 classrooms. Before you even get into the data and the question, which is the smallest box top collection? Which is the biggest?
159.
159, okay? So we've got our max and our min there already. It then says, the sum means to add, the sum of the box tops collected by the 2 rooms with the fewest boxes is approximately what percent of the sum of the box tops is of the larger, or the 2 ones with the most top.
80.
So what are the fewest 2?
100 and 206.
300.
Room 100, yeah, sorry. Room 100 and room 206. Room 100 has,
600.
and room 206 has,
300.
so we have 600 plus 300 for that first sum. Then, it then tells us, and it asks, it's what percent of the sum of the box tops collected by the rooms with the most. So we have to add those 2 together. What are the most? 1,800.
So it's 1/2.
So, to do this problem, I want to think of this. I think of this as 900. This is 1,800. Now, it says, what percent is the smaller one of the bigger one? 50%. Here's a little question for you, make it a little tougher. If the problem said, what percent is the fewer sum of the whole now?
You have to add all of that and divide it.
If it was the fewer one out of the whole, the fewer is still what?
300.
Not 900, right? The few,
Add all of
sorry, the 2 fewer of the whole. 2 fewer, sorry. And then what do you do with them, Kelly?
you add all of them.
So what would the denominator be there? Come on. 9 and 18 is 27, so 2,700. You guys know this. Do it this way. The smaller is 900, the larger is 18. 9 plus 18 is 27. Yes, that's fine. What's 9 over 27 when I cancel those zeros then?
30.
1/3 you mean, not 3, right? So it'd be 33% if it was that one. Okay, approximately 33. Now, if somebody did that, what answer would they choose?
30.
They would choose A because it says in the problem is approximately. And 33.3, this is really 33.3 repeating forever. If you were to round it, what's the closest one? 30% would have been the closest. So if you did the total instead, you would have gotten the wrong answer. But our problem said What percent of the larger is the smaller? Last problem. Can I get a reader for this one? That's not me again. I wanna. There's water on there.
Two classes were given a math test. The first class had 25 students and the average test score was 86%. The second class had 15 students and their average score was 94%. If the teacher combines the test scores of both classes, what is the average of both classes together?
Yeah. I should put the really.
Isn't it 90?
Andy, I think it's the wrong way. You just made a common mistake. I'm kind of glad though, so we can learn this. Okay? Because I was going to ask, what's the common mistake? And it's 90. You want to think 90? Why? Andy, explain to us.
It's in the middle of both.
Yes, this is 86 and this is 94, right? Those are your averages. What's in the middle of those? 90. 90 is smack in the middle. Here's the problem though. You don't have the same amount of students in both classes, right? So it's called a weighted average. And I'm going to explain to you how to do it right now. It'll make a lot of sense. Start with your formula for average for both. 86 is equal to whatever the sum is over however many students. How many students took the test that had 86%? And I'm going to call this sum 1. Okay, again, not sum 1, but sum subscript 1. The average always equals the sum over the frequency. So that's my first equation. My second equation, what's it going to say? Sum 2 over, be careful, 15 students, where is that? 15 students in the second class. 25 was in the first class. Now, here's what you need to think about. An overall average is the sum of everything divided by the frequency of everything. So we need to find the sums so that we can then combine them and divide it by the total amount of students. What is the sums of each? 2.50. And? Okay. How did you get those? What did you do with the numbers in the bottom? Good. Multiply them on both sides to get rid of them. Take the 25, multiply it over here. Okay, so sum 1, not sum 1, and sum 2 are listed. Now, to get the overall average, it's the total of the sums. Okay, the total of the sums. So we could say the overall average, x bar, is equal to the sum of the sums, which is redundant but true. The sum of this symbol right here is called sigma. It means the sum of the other sums, all over the total students. Good. So we got 35, 60. No. 36. Thank you. Are you sure those numbers are right?
Yeah.
I didn't get those, I don't think.
I don't have those.
I got 2150, but then I got 1410 over here. That should be 1410. Okay, so make that correction, please. Now, if I add those two numbers together, 2150 and 1410, I do get 3560 now. And what's 3560 divided by 40? It's just 89. I'm going to talk about this now in a minute. So let's bubble in our answer first. 89 is the average. Andy, let's go back to your first thing you said, okay? You said that 86 and 94 are equally spaced. And what's in between them? 90. So 90 is in between those two numbers. But one of the classes has more students. So it has more of an effect on the average. If I had a class of 2 students and a class of 75 students, and I said I want to find the average of both classes, I can't just average the classes because it's not fair. We got 75 kids with one average and only 2 with another. So you can't just average them equally. So what we do is this. Take a look, people. Look at the beginning. Which problem or which average had more students?
A.
This one here, right? This had more students? A, or the first one? This had 25 students, whereas this one only had 15 students. Which tells me that my average of both classes is going to be closer to this one. And what's the overall? We said 90, right? It would be? What's something a little bit less than 90? 89. So for this kind of a problem, here's what you do to start. You know it's not going to be 90, because now that you learn weighted averages, you cross that off. It can't be 91, because 91 would mean that it would be over here, which means that there would be more students in the class with an average of 94, actually. So it's got to be one of those 3 choices. So even if you didn't know the actual answer, now you can take an educated guess. Okay, now it's a chance to take a guess. Personally, I never guessed unless I was able to roll down to 2. Okay, I never did.
But you're good at math.
Okay, it helps, but I would say like here, 87, 88, 89, how do you really know which is the answer? You don't know. Granted though, if one of the choices had been 85, let's make believe this was 85. Why can I cross that out, Kelly?
Because it's like lower than the other two.
Yeah, this average is 94, this average is 86, which means there's got to be somewhere in between those. And 85 is outside of here. So then, it's worth an educated guess. Yeah, then it's worth an educated guess. Now, before we stop, before we call it quits today, you're going to get homework. Your homework is going to be to do these 6 different problems. Please don't just quit on them right away, because some of them are tough. Think about them. Use x, x plus 1, x plus 2. Use stuff like that, variables if you have to. This is going to be over the weekend to do this. In addition to that, here's what I've done. To give you guys a little preview of the SAT if you haven't been doing the online class. There's a section for everybody to work on over the weekend on their own, or actually today or tomorrow, really, because your test is Saturday morning. It's a 20-minute section with 16 problems. Do your work right on here. After the section is over, though, at the end of the section, after that, you're going to see I have a solution afterward. So all of the answers are here as well. So check your answers and read my solution and see if it makes sense. Now, please time yourself to get an idea of how you're doing. Okay, please time yourself. Do not read directions on here. You'll never hear me say that again. Do not read directions on the actual test. Today and tomorrow, become familiar with the directions. Make sure you have them not memorized, but fully understood. So when you take the test, you don't waste time. You hear me? Again, you cannot open the book ahead of time. So they'll say go, and then you have to start. If you read the directions, that's a waste of about 3 minutes at least to read this. You only have 20 minutes. Please, don't waste 15% of your time just reading the directions. So what you need to do is make sure you're familiar with them. They're identical. This is the exact wording as the SAT. Okay, it's a practice section, but it's identical. Now, what I've also done for you guys is this. I don't encourage cramming. I really don't think it's going to help if in the next 2 days you just do a million different sections, or you try to watch all the videos I've been putting online. So if you'd like to, though, what I did do was this. I summarized the most important stuff. I summarized the most important stuff in one folder. So if in the next 2 days, so say, say for example, okay, now, say you have some free time in the next 2 days. You might want to look at some of this stuff. So, go to your class. Here's our class right here. Open up our class if it actually loads. Come on. Now, in the class, I have that folder in the upper corner that says SAT Online Math Class. So go ahead, click on SAT Online Math Class. Once that loads and opens up, you're going to see all the week stuff that I started putting in. By the way, I never went beyond week 7. There were 11 weeks. But by the time I got to like week 5, people weren't watching the videos. So I stopped doing it, to be honest. So you're not going to see those there. But what you do see is this. Documents to review right before the SAT. I thought, can't be any more clear than that, right? So, you click on this one. Inside of this folder, you're going to see 5 documents. One of them is a formula sheet that goes over all the formulas in the beginning of the section here. And it describes when you would use them and how to use them. Next, over here. Oh. Oh. Thank you. Next, after that, there's a section that says math strategies. What's that?
These ones.
Oh. Thank you. See, I forgot about those already. Next, there's a document called Math Strategies. It is worthwhile. Math vocabulary. I mean, look at the vocab one. Watch what this loads up as. This is really worth it. It goes through all the major stuff. Integer, remainder, even, odd. Keep going. Multiple, positive, negative, factor, prime, average, median, mode. See all this stuff? You got to know what these words mean. So, with that said, if you want to study in the next 2 days, I would recommend, you don't even have to print it, guys. Just on your computer, view it. If you want to print it so you can bring it places with you, like on the metro, on the way to work to read, then you might want to print it in the library today. Maybe print 1 or 2 of them to read. But don't waste a lot of paper. You can just click on it and read on the computer. Okay, or go to your library if you need a computer so you can read it down.
You know how we take an SAT on Saturday and another one next year? Isn't one next year going to be senior level, or is it going to be like
Same thing.
Oh, okay.
The SAT doesn't change whether you're a senior or junior, no. It's just like, you guys really want to focus on doing well in this one. It will help you in the long run, okay? You don't want to have a lot of pressure in October to do well in SAT so that you can send it to a college. Do well in this one, okay? Do your best, obviously. I hope you do your best, you know? Now, some pointers and tips. I put a lot of tips here under SAT Math Overview that I wrote, but some general things to say. First, you got to eat. You can't not eat before this test. Eat breakfast. Okay, you want to write down, but remember, protein. Best thing to eat if you want to wake your brain up fast is protein. Okay, but coffee is not going to do you good, because 3 hours in, you're going to crash. Please, guys, don't just rely on coffee. You need actual food, real food. So, protein. Something like, I know this is weird, but in the morning, the best thing, actually, fish. Like a piece of flounder. A lot of countries use fish, flounder, or salmon, or something with protein in it. Even like a cheeseburger, but a real cheeseburger, not McDonald's, okay? You can't even get McDonald's at 7 in the morning. You can't get a cheeseburger that early. So, at 7 in the morning, maybe the night before, and put it in the fridge. But eat protein, guys. Next, carbohydrates. So have some sort of bread. Have some bread. Some fruit. Natural fruit juice is very energetic. An apple gives you more energy than a full cup of coffee. Most people don't even know that. Okay? An apple gives you more energy than a cup of coffee. Now, on the test, during the test, bring snacks to eat. You cannot eat while you're taking the test, but you have breaks. Put snacks in your pocket, load them up. Okay? Load up your pockets with snacks. Doesn't matter, you can do that. And eat them in the hallway or in the bathroom or wherever you have to. Eat the snacks though when you get a break. Next, take the break. Take the actual break. People, they go, you have a 5-minute break. You know how many students just put their head down? You're going to be so tired in the next section. It's not going to help you to take a 5-minute nap at all. Get up, do some jumping jacks, walk around, do something to move around. Okay, do something. What else? Bring 2 pencils, not 1. Okay, bring 2 or 3. No mechanical pencils are allowed. Calculator, normal calculator only. Cannot use your phone by any chance. If you still haven't got one, borrow one from your best friend that's a senior or a sophomore that has their own. Do not rely on us to have them. We're not going to have them. Bring your own. Trust me. Trust me. Bring your own. Okay? Borrow one if you need to for now. Do not rely on other calculators. Batteries. Make sure your calculator is working and you're not low batteries. If it says you are low on batteries, you might be replaced soon, don't wait until after the exam. Do it now. Okay? Get some batteries. Let's listen to an ad.
Attention, please.